This is a Onkyo CR-305FX. Apparently it doesn't start up. Okay, this is the Onkyo with the top off. That's the power amplifier section. The fault with this unit is that it doesn't switch on. So, place to start with this sort of fault is this board here, which is the power supply. Now, the interesting design of this, you've got the transformer is actually soldered onto the circuit board that is the power supply. Now, I've actually had a look at this unit already, and the fault turned out to be this capacitor here, C913, and fortunately that capacitor is actually easy to get to because it's here. There's its connection, so you can actually remove that without having to take the whole thing to pieces, which is actually extremely useful. Now, that capacitor is on the power supply. I'll show you the waveform on the oscilloscope of what it looks like. But basically, it's a 5-volt rail that goes into the microprocessor that tells it that the power is switched on, and because the smoothing capacitor on it had failed, you were getting it was like a sort of ripple on the signal. I replaced the capacitor and it has actually fixed the fault. This is the circuit diagram for the Onkyo. Now remember, the original fault with this, it wouldn't actually switch on at all. So if you've got a similar problem, you could start by measuring the resistance across the mains, live and neutral pins on this unit. It was about 29 ohms. If it's open circuit, either that fuse there is blown, which if it has, the transformer's fit for the bin. If that fuse there is blown, you can replace it and hopefully it'll work. Make sure you replace it with the same type. Then what we've got on this connector here, this is a 9-pin connector along the top edge of the power supply board, and it's easy to get to, and it's a good place to measure the voltages. So pin 1's got 12 volts on it, but if the unit hasn't actually switched on, you won't get 12 volts on there at all, because this part of the circuitry, which also, there's two great big capacitors on the board, they provide the main power to the amplifier, which are called plus B and minus B. That'll be dead as well, because this relay won't actually be closed, so this bit of circuitry isn't powered up at all. So down on this lower part of the circuitry, this power supply here is always powered up because it just comes straight off a winding on the transformer. So we've got a bog standard bridge rectifier here. That isn't a rectifier package, these are separate diodes on the board. We've got a 5.6 volt regulator here, so you should always, 5.6 volts should always be there. This minus VP, I think I've read about minus 25 volts on that one. The 5.6 comes off this regulator here, so you should always get 5.6 as long as the regulator is working. We've got a couple of grounds, then we've got a P off, which I'm guessing stands for power off, and power. Now, this last pin, power, is what actually activates the circuitry, so that the microprocessor, if it's happy that the unit's safe to turn on, it'll switch this transistor on here, which turns this relay on, which then closes this relay here, which will then pass power into the main amplifier and produce this 12 volts. The problem with this circuit is this capacitor here, C913, had actually failed. So what we were getting, instead of getting a nice smooth DC voltage here, we were getting a signal that looked like this. This center line of the scope is the ground, so the signal was bobbing up and down like that. It was flattened off on the top because this point here, it comes off down here. It's got the Zener diode, a 5.1V Zener diode, sort of limiting the voltage to 5.1 volts. So that's why that signal looked clipped. Now, if you measured this point with an oscilloscope, with a voltmeter, you didn't get 5.1 volts. I think I read about 4.1, which either wasn't enough to tell the microprocessor that circuit was good enough, or the processor was actually clever enough to detect that it wasn't a nice flat DC waveform. So when I replaced C913, waveform went from this horrible one to this nice flat DC one here. It's got quite a lot of noise on it, but so this voltage here would have been 5 volts, and when that was replaced, the unit burst into life. So there's a couple of pointers for you on here. There's a lot of diodes and things that could fail, and a few transistors, but on this particular unit, as I say, it seems to be a fairly common problem is that this capacitor there, C913, fails. It's 47 microfarads, 35 volts. Cost you pennies. Okay, thank you for watching.